Well, I don't have the bottle in front of me, but the peroxide in that initial peroxide solution completely reacted after about 20 minutes. I didn't want to heat it too fast, drive off the vapor, because in the reaction, we're wanting to generate two things, just water, which is, of course, safe, but then the oxygen gas has to be completely released from the initial peroxide solution. And remember, this peroxide solution does not have 100% peroxide. That'd be very dangerous. It's about 30% peroxide. The point of this peroxide lab is to determine experimentally what the percent H2O2 is in the solution by weight. So to do that, here's what you'll have to do. This will be very important, so you may want to watch this video a couple times as I introduce the logic of how to find that weight percent of peroxide in your peroxide solution that we ordered from Aldrich. First of all, there were some initial weights. There was the weight of the bottle, the weight of the bottle with the catalyst solid, the used spent hands. Then the peroxide was added, and you can see that there was a very big jump in weight. So we had roughly 30 grams, I guess, of our peroxide, and that's a very important number, weight to have, is the weight of the total solution. This is the solution, water with peroxide. It's a dilution of peroxide in water. So this again was the weight of the bottle, the water bottle, the weight of the water bottle with that solid added, the catalyst, the weight of the water bottle with the solid and the peroxide. So it's kind of an addition of weights as we go. Then I let it sit, and you saw in the video that the reaction proceeded. It took about 20 minutes again for it to completely remove oxygen gas, and the weight lost then is about 5.1 something grams. It lost that oxygen gas. This is how that weight changed. The oxygen gas was released from the peroxide, leaving water and oxygen gas, which of course is boiled off or is given off and does not become part of the weight. So this is really the difference between these two, is the weight of the oxygen, and that's key, because from that you can then determine, if you know the weight of oxygen lost, you can use molar mass conversion to determine the moles of oxygen gas lost. And if you determine the moles of oxygen gas lost, you can then use this equation. For every 1 mole of oxygen gas formed in these equations, it means that there were 2 moles of peroxide solution initially. So again, this is a balanced equation. If you know the moles of the oxygen gas, if it would say, let's say it was 10, then it must be 20 moles over here, because we have to double it. For every 1, we started with 2. So by using the moles of oxygen, you can use the equation above to determine the moles of H2O2 that were in the peroxide solution. Now you're turning a corner, you're getting close to being done. Now you can determine the weight. If you know the moles of H2O2, you can determine the weight of the H2O2, the peroxide, hydrogen peroxide, that was in the peroxide solution. And remember back, the weight of the solution was the difference between these two values, because this is where the solution was introduced. And now you know the weight of your peroxide, you know the weight of the solution, you just do part over the whole to determine the percent H2O2 in your initial solution by weight. That's the lab for this week. That's online, completely online, and I've of course obtained the data for you. Have fun. It's calculation rich. Make sure your lab notebook that you submit pictures of has a title, has an objective, has the chemical information for hydrogen peroxide, the NFPA code that we've talked a lot about in the lab. If it's a health of 2 or 3, make sure you put health a 2, or if it's flammable, it has a high value up near 4 of flammability, then put 3 or 4 and put flammability and then have a 4. Those are important. Have under experimental, you don't need to put anything, but you do need to go ahead and write the results as I have it written here. And of course, not just these steps to doing calculations, but the calculations themselves have to be shown. It needs to be clearly formatted so I can read it. If I can't read it, I can't grade it. It'll just be out of hand, graded as a 0 for that section or for the entire lab. Make sure you have spacing between the headings, results, and calculations. Thanks. Bye-bye.